So, solving systems. If you're asked to solve a system like in number 30 here, and notice there's 3 unknowns in each equation, but the system only gives me 2 equations. That type of system is called a non-square system. All right? A square system is if you have 3 unknowns, you get 3 equations. 2 unknowns, 2 equations. 4 unknowns, 4 equations. So if you don't have enough equations for the number of unknowns, it's called a non-square system. When you solve it, what happens is you can't really get a unique one-ordered triple solution for this. So you get a solution that will give you more than one answer. So the answer is not unique. So let's get our answer bracket set up here. So I have to have 3 answers for my x, my y, and my z. But they're not going to be unique answers. They're going to be little equation representations of the answer. But you start off solving the system the same way you normally would. Now, I'm going to choose to eliminate z, but you could choose to eliminate y or x if you wanted. So, if I choose to eliminate z, I could multiply this first equation by -5. So, I'm going to times by -5, and when I do that, I get -10x minus 15y minus 15z equals -35. You with me so far? All right, I'm going to keep this system exactly as it is. So 4x plus 18y plus 15z equals 44. What do I do next? Hope you said add. All right, -6x plus 3y equals 9. I notice this reduces, so I'm going to reduce it. Minus 2x plus y equals 3. And then I'm going to use this equation twice now. I'm going to solve it for y, and then again I'm going to solve for x, and use it 2 different ways. So when I solve this for y, I get y equals 2x plus 3. That is going to be my cool substitution, okay? I'm going to go back to equation 1 with that substitution. And in place of y, I'm going to put that. So, 2x plus 3 times 2x plus 3 plus 3z equals 7. You with me so far? And then I'm just going to solve that out. So 2x plus 6x plus 9 plus 3z equals 7. Now I'm going to add my like terms. I get 8x plus 3z equals -2. Move that 9 over. You with me? All right, let's solve this for x. So x equals 3/8z minus 1/4. All right, there's my x representation. That goes here. 3/8z minus 1/4. Now, we're going to take this same equation again, and this time we're going to solve it for x. Remember the first time we solved it for y. So I kind of plan out what I'm going to do before I start doing everything. Sometimes you get carried away and a little bit lost. So now I'm going to solve that for x. So when I solve that for x, I get x equals y minus 3 over 2. Hopefully you can do that. And remember here, once I solved for x, I circled it, and I went to where? The first equation. So I'm going to go to the first equation again, this time with my x. So, you with me here? 2 times y minus 3 over 2 plus 3y plus 3z equals 7. Now, I'm going to just simplify that. So y minus 3 plus 3y plus 3z equals 7. And I'm going to solve that for y. And y equals, let's see, 10 fourths, 5 halves minus 3z over 4. There's my y. 5 halves minus 3z over 4. And since I put everything in terms of z, z is the last number there. Now, the textbook uses a for the variable. And so what they do is they would have this same answer, and they would rewrite it. Let me clean up my board first. Okay, so what the book does in terms of this, because this ordered pair uses one of the variables that I started with, it's considered not really cool, so a better, more standard answer is to say, let a equals z. So the ordered triple would really be 3/8 a minus 1/4, 3/4, negative 3/4 a plus 5 halves, and a. And basically what this means is you can have multiple answers for this problem depending on what you choose to have a stand for. You could have a be 0. So you could have a ordered triple that would be a, it would be 0, 5 halves, and negative 1/4. And of course you could test that in the two equations and it should work. You could let a be 1, and then you'd have negative 3/4 plus 5 halves, figure that out. You might want to test some of these multiple answers. Anyway, there's not a unique solution when you have a non-square system. And again, remember, a non-square system just means that you don't have the right number of equations to match the number of variables. 3 variables, I should have 3 equations to solve the system. 4 variables, you should have 4 equations to solve the system. If not, non-square system. Good luck.